So in this video, we want to see how we can construct the incenter and incircle of a given triangle. So here we have a given triangle, and the first thing we are going to do is label the vertices. So we have our vertices A, B, and C. So this construction has several parts. The first thing we wish to do is to find the incenter, and to find that we are going to bisect two of the angles of our triangle, and where there are two lines of bisection intersect, that will be the incenter of our triangle. So the first angle we are going to bisect is the angle A, and the bisection of an angle is the first construction, so we're going to do it exactly as we would have done in the video for the first construction. So first off, we'll draw a circle centered around the point A. This circle can be any radius you so like. And once we have drawn that circle, what we are going to do then is highlight the 2 points where this circle intersects the arms of our angle. So the next thing we are going to do is draw 2 further circles, one centered around each of these 2 new points. 2 conditions on these circles: they must be of the same radius, and the radius must be greater than half of the distance between the 2 circles, because we want for these circles to intersect. So we'll draw the first circle now. Okay, and now we'll draw the circle around this point, and again it will have the exact same radius as this circle. Okay, so what we want to do now is highlight these 2 points of intersection, like so, and if we draw a line through these 3 points, that line will be the bisection line of this angle A. Okay, so that's the first angle done. We're going to do the exact same process at the angle B. So first off, we'll draw a circle around this point B. Secondly, we will mark the points of intersection of this circle and the arms of our angle. We will draw 2 circles centered around these points. Again, the circles will have the same radius, and the radius must be such that it's greater than half the distance between the 2 circles. Once we have drawn these 2 circles, we will mark the points of intersection, and we will draw another line through these points of intersection, and that is the bisection line of our second angle. So this point here, where these 2 lines intersect, we'll call it O, and this is the incenter of our triangle. Okay, so that's the first stage of this process, and what we're going to do now is I'll just fade out these construction lines a bit. Okay, so we faded out those construction lines, and what we want to do now is we want to find a line from this point, a perpendicular line to one of the sides of our triangle. So we're going to go with the side AB. So if you're not sure how to draw a line perpendicular to a given line from a point not on the line, what we're doing here is just construction number 3. So first thing we'll do is draw a circle which will cut this side AB in 2 places, and the circle will be centered around this point O. Okay, so now we're going to highlight these 2 points of intersection, like so. And what we're going to do then is draw 2 circles, one centered around each of these 2 points. Again, the circles will be the same radius, and the radius will be greater than half the distance between them, because we want these circles to intersect. So we'll draw our first circle here. We will draw our second circle here. Okay, and we're going to mark the points of intersection of these circles, And now we will draw a line through these points, and this line will be perpendicular to the side AB of our triangle. Okay, so our construction is nearly complete. What we wish to do now is mark this point where this perpendicular line cuts the side of our triangle. And finally, we're going to draw a circle centered around the point O, and the radius of this circle will be the distance from our point O here to where our line intercepted the side AB of our triangle. So we'll draw that circle now. And that circle is the incircle of our triangle, and you can see it touches all three sides of our triangle. So that's our construction complete. And what we're going to do now is take a look at why this construction works. So to see why this construction works, we have a tidied up image of our final drawing. I've removed a lot of the construction lines. I have drawn lines BO, AO and CO, and they are from the vertex of our triangles, or the vertices, to the incenter. And we have this point here, which we will call P, and that is a right angle, and that is a bisector, a perpendicular bisector of BA. And here we have a point we'll call Q, and Q is a perpendicular bisector of BC. So if we now take a look at the triangles BPO and BQO, we can see straight away that the line BO is common to both of these triangles. So we can say that the length of BO is equal to the length of BO. We also know that the angle PBO is equal to the angle QBO, because this line BO came about from the bisection of this angle B. So we can say the angle PBO is equal to the angle QBO. Now, because this angle is 90 degrees, and this angle is 90 degrees, and this angle here, PBO, is equal to this angle here, QBO, then we have the angle BOP, which we'll call this angle here, must be equal to the angle BOQ. So we can say the angle POB is equal to the angle QOB. And what we have now is we have two congruent triangles, and they're congruent by angle, side, angle. Because they are congruent, this gives us that the length of the line segment PO is equal to the length of the line segment OQ. Okay, so we have just shown that the length of this side is equal to the length of this side. By the exact same argument, if we drew a line perpendicular here, we could show that this side here is also the same length, and we have the length of PO is equal to the length of OQ. If we call this point OR here, we would say, and that is equal to the length of OR. So what we have shown is that our circle is tangent to the three sides of our triangle and touches them at points P, Q and O respectively, and so is the incircle of our triangle, and our construction is complete.